Welcome to AP Chemistry. Today's lesson on the stoichiometry of compounds is part 4, determining molecular formulas. Previously we've covered the meaning of molar mass, how to calculate molar mass from a formula, and also how to determine the empirical formula of a compound. Today, we're going to learn how to determine the molecular formula of a compound from its empirical formula and molar mass. Let's review the difference between empirical and molecular formulas. Empirical formulas are the simplest ratio of atoms in a compound. All substances have an empirical formula. A molecular formula represents the actual types and numbers of atoms found in a molecule of a molecular compound. And so while, as I said, all substances have empirical formulas, only molecular compounds have a molecular formula. A molecular compound might be made up of more than one of its empirical formula units. For example, glucose, whose empirical formula is CH2O, has a molecular formula of C6H12O6. Each molecule of glucose contains 6 empirical formula units. We need to do two things to determine the molecular formula of a compound. First, we need to determine how many empirical formula units are included in the compound's molecular formula. This requires two steps. First, we calculate the molar mass of the empirical formula, and then we divide the compound's molar mass by the molar mass of the empirical formula of the compound. This will tell us how many empirical formula units are contained within the molecule and the molecular formula. Obviously, if two molar masses are the same, that implies only one empirical formula unit is contained in the molecular formula and that the two are in fact the same. Next, we need to multiply each of the subscripts from the empirical formula unit by the result of step 1. The result from step 1 is the number of empirical formula units contained in the molecular formula of the compound. Our first example is of a compound with an empirical formula of CH and a molar mass of 104.1 grams per mole. While working through the calculations, I'm going to eliminate using units just to make the calculations more clear. Let's find its molecular formula. We'll start by finding the molar mass of the empirical formula. We've got carbon and hydrogen. 1 times 12.01, the molar mass of carbon gives us 12.01. And 1 times 1.01 gives us the molar mass of the hydrogen in the empirical formula for a total of 13.02 grams per mole. We're now going to take the molar mass of the compound, 104.1 grams per mole, and divide it by the molar mass of the empirical formula, 13.02 grams per mole, and that gives us the unitless number 8. This is the number of empirical formula units in the molecular formula, or in a molecule of the compound. So we're going to take 8, we're going to multiply it by the subscripts in the empirical formula, and so we end up with a molecular formula of C8H8. In our next example, we have a substance with an empirical formula of KCO2 and a molar mass of 166.2 grams per mole. We'll find its molecular formula by first determining the molar mass of the empirical formula. So we've got 3 atoms, potassium, carbon, and oxygen. 1 times 39.10 grams per mole, the molar mass of potassium gives us 39.10. 1 times 12.01 grams per mole gives us 12.01. And 2 times 16, since we have 2 oxygen atoms in the empirical formula, we have to multiply its mass by 2. We get 32 grams per mole, and the total mass of the empirical formula is 83.11. We now take the molar mass of the substance, 166.2 grams per mole, divided by the molar mass of the empirical formula, 83.11 grams per mole, and we get 2.00. That's the number of empirical formula units in a molecular formula, or in the molecule of this substance. And so when we multiply 2 by each of the subscripts in the empirical formula, we end up with a formula of K2C2O4. And you may recognize C2O4 as the oxalate ion, so this compound turns out to be potassium oxalate. So let's recap what we've learned. To determine the molecular formula of a substance, we have to go through several steps. First, we have to calculate the molar mass of the empirical formula. Next, we're going to divide the molar mass of the substance by the molar mass of the empirical formula. This will get us the number of empirical formula units in the molecular formula. And lastly, we're going to multiply the subscripts of the empirical formula by the number of empirical formula units that are in the molecular formula, the result of step 2. And that will get us our molecular formula.